I'm going to start off by swapping one of these circuits for SSG. I'm going to put SSG in here and we're going to get different output. We're going to leave our generator on there though, so. Alright, we're going to put those ones on last. Then, okay, we want to go down with this. There we go. Alright, so that is the red, the trigger. Alright, hello everybody, what's up? We're hooking up an SSG circuit today. Okay, so my kids are up and moving around, very distracting. Always want to see what they're up to. So that's going to go into the red, or the positive of the drive coil. And this one, we're going to add another one for this one. This is going to go into the power. This one. And this is going to go into this one. That's the positive, negative of the trigger. Trigger's hooked up. Alright, so the transferring is a little different than hooking it up straight. It's a little different. So we need a clip. I don't like using these clips, but right. So that's hooked up. Ahoy! How's it going? Alright, let's see here. Ground. And the live wire for the load. Okay, that's good. Now I can hook up the power. Sweet. Might have to double check and see what's what over there. I'm gonna do that real quick. So yellow is positive and green is ground. Yellow is blue. All right. Sweet. SSG. So right now we have an SSG hooked up to this and a 1, 2, 3. Bing bang bomb. Let's see here. It's a 12-volt system, so we'll do it on her. Put 12 volts in. Oh yeah, that's good output. It wasn't really doing good spin though. Something not right with that. It might be the series circuit in the actual coil that I've got hooked up. That's pretty sweet. I mean, it is a high pitch, it's on very high pitch frequency for, well, it's not that bad, actually. I know this one doesn't squeak at all with the 1, 2, 3, really. It just kind of scoots. You can hear it scooting. But it's powerful. There's like no resistance. You only got your light bulb in 1, 2, 3 circuit over there. But you don't get this. I don't know if you can see it. You can't really see it. I'm gonna have to move this. See there? So this is coming out the generator circuit, the 180 degrees. It's two 32 gauge coils. One's 18,000 with a soft iron core, and the other's 22,000 with an iron filing core. And that's generating this, which is very stable. It's not this one is pulsing a lot, but it's okay, it's good. This one's very much brighter than the one on the table. Alright. So I think that's cool. Have that extra light going. This is just the SSG. I bet it's going to stop. And I think it's because of the way the coil is. might be the transistor. I'm not entirely certain. I mean, it works okay, but there's something wrong with it, for sure. So I'm just getting a bearing. Oh, my cat wants to come in. There he is. What's up, Tiggs? All right, so I'm going to put this bearing in the bottom of this. I'll lift this one out. There's no magnets on this, so I'm not run. This isn't going to be a motor demonstration at all. I'm just testing the spinability and seeing if the design is okay. Then I'll explain to you what's going to go into this. It's all right. It's not too terrible. All right. So as soon as I figure out what this thing is called, I'm gonna print some of them. And what it does is it holds this shape, Utron, in these slots at a 45-degree angle to maximize spin, rotation. And if you hold it at a 45-degree angle, you'll see exactly why that is the case. Yeah, you can spin it by putting it directly on the axis here, but that's not your maximum spin. Your maximum spin is the maximum surface area the magnet is affecting. And if you get it right, I mean, what I'm saying is it could be a very small magnet that makes this work. So every other, you get a neutron in its little holder. That's all I don't know. It's called a holder. And then every other, you have a sheet of aluminum that stretches from the top, curves around, and goes all the way back to the middle on the bottom. And it's one piece. And then it's bolted on with one bolt, according to this presentation that I saw. You get one bolt. And it's got to be a nylon bolt. Oh man, I'm on the blacklist or something. It's all right though. I don't know what it could possibly be. Just kidding. So, what I was wanting to explore today, actually, let me get my mic up. I hope it's charged up. My voice is shot. All right, we are almost there. There we go. Yeah, my voice is cached right now. It is most of the time. Let me just get this on. There we go. All right. So I finally figured out maybe a reason why I did do this stuff is because I don't know. This is my workshop, and I'm a dad, and it's my dad's workshop. So kind of doing it for my kids. I know there'd be a lot of logical people out there that would say that's just not true, but I don't know, man. I'm thinking kind of that it is true. I mean, I do it for myself for sure, but if there's like a purpose or a reason, I mean, everybody's like, your experiment has to have a conclusion before you experiment, or it's not an experiment. Well, then I don't know. I'm just effing around then, because all I wanted it to do was move on its own, basically. And when it did, and somebody told me how to do it on YouTube, and I did it, and it worked. First was a reed switch, and it worked, and I was like, yay! I was so happy. Didn't realize that happiness might be short-lived. You know, that's like, but no, I'm still happy about it. I'm not saying I'm not happy about it. I'm just saying there's been some bumps in the road along the way that I didn't anticipate. That's all. Oh, but I want to emphasize again, I was watching a presentation over on a different channel, and they were mentioning force fields and different types of force fields. And I was just wanting to say this, that you can make a bunch of coils that could produce number 2 force fields. There you go, man. You can elevate the infrastructure like we elevated our buildings. You know, you can elevate the infrastructure the same way, same concept, by using number 2 force fields to, you know, repel or stop a certain type of metal. Right? It makes sense, doesn't it? I mean, you could use those force fields to basically make everything that's around today be able to fly and be retrofitted. Not only can you retrofit the old cars to be able to fly, but the new ones could just fit right on it and, you know, not have to be retrofitted. I don't see why we can't use this war tech for practical uses at home. I mean, we do with other tech. Why can't we use this tech to do the same thing? That's just my question, my curiosity. I think we should be able to use this tech to improve our quality of life. because my traffic is bad where I'm at. It's a 2-lane road, one going one way, one going the other. But yeah, I can barely get out of my hood ever. It's like, come on, man, something's got to give. Wow, people are so rude. It's all right. You can be as rude as you want. You can be as quiet as you want, as silent as you want. You can call the local authorities if you know where I live. You can do whatever you want. I'm not doing anything wrong. And it doesn't matter how deep and dark your explanation of what I'm doing is, I'm not doing anything wrong. It's okay. It's all right. Even though I'm not doing anything wrong, and I could probably get in trouble with somebody who lied well enough. I mean, when you're talking, when something isn't worth kicking around. And I can't blame a jarhead for being a thug. Of course, I mean, if it triggers your PTSD, I apologize. But I mean, I've been accosted by everybody from you to, I got messages from the Illuminati, crazy crap, like, yeah, right. I've gotten messages from just, people that need to keep their mouths yipped, man. Just zip, 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 zip. Sorry. Oh, I apologize, man. I really do. For those people that I'm not talking to, I'm not talking to you. But for those people who kind of, understand what I'm talking about, it's like, yeah, come on. Who wants you around doing that? Yeah, reciprocity. You understand? Good. And then, like I gotta say, hi, B. Oh man, so good to see you, man. I really appreciate you stopping in. I don't even know if these people are trolls. They're not even really trolls. They're just people that are misled. See, with a true troll, the intent is different than with somebody who's just, oh, I watched this thing last night and they said that what you're doing is wrong. That's different. It's different. It really is, man. But it's still ignorance. And it's not like it's wrong as in you're doing it wrong. I said they were trying to tell me it was like wrong as in you shouldn't be doing it at all. And I'm like, oh, wow. Thanks, Pete. I really appreciate you, man. I should have looked up sooner. So if somebody knew or knows or might know the name to the thing, the holder for the Utron, it rests in the Utron, holding it at a perfect 45-degree angle. And it has, it's all with the bearings and everything. Oh, we got the sphere up to 40 hertz last night. Yeah, yeah. Well, it starts with a T, B. It's a specific, it's sacred, man. It's specific. It starts with a T, and it's designed specifically to hold things at a 45-degree angle. So it's like it starts as one piece, and then you break it apart. And then when it gets to the the distance of what you're trying to hold, it'll be at 45 degrees. It's an awesome thing. Yeah, but a cradle gyro is basically what it is. Except it only has to spin. In this specific instance, it's only going to spin. It's not going to twist and turn. All that's going to be is on its own through electromagnetism or whatever else we're using when it's done. Like the ether and the crystals and all that. I think like if we're going to go that route, kind of, we should stay. Come on, Tiggs, don't jump up on the table with that type of energy. I don't know about making bridges. That's a little fun, but maybe like a bridge rectifier, for example. and use that. And if there's any way to put ether energy in, transmute it or transform it into AC and DC, or do you even need to do that? I don't know. I don't know if you would need to do it if you had harnessed or mastered harnessing the other type of energy. You need to transform it into AC and DC. But if you can, I would rather do that because I'm getting to know this electricity a little bit better. But I mean, these look like just regular Utrons, but they've actually got a hollow spherical center. So there's a chance for ionization to occur. At least that's what I was told. And that's why I printed them that way. For ionic reaction to occur. And I think if everything's spinning, that's going to cause a bubble. Because you've got neutrons at every 60 degrees on the rotor. If we like expand those, if it creates an ionic field and we expand those fields, it's going to, overlap, of course, and it's going to create a larger spherical, or not a spherical, but more of a honeycomb. I can't really see the outer edge, but I know that they're going to overlap to the point where I'm talking about ionic fields. So you got one of these, and it puffs out a field when it's going spinning real fast. That's like a purple or a pinkish, right? And I mean, the inside is a sphere, so I don't know. Don't really know the science on that stuff, but I know what it's supposed to do. And then you put a neutron every other one, and those fields are going to overlap. And they're going to expand out this way too. So it's kind of going to, maybe like a daisy even, or a butterfly. I think I might have to print all this again. But I don't think I can do it that way. That would be cool though. Just print this inside its holder so that it'll spin optimally. That's what we did with this gyroscopic pulse motor rotor. Let me get it real quick. All right, so we printed this whole thing as is. We printed it as is, and it gyros. So I was thinking about doing the same thing with the Utrons. You see, when you spin this by hand, the middle one spins too, but not until the end of the spin. It's like awesome. And that's because of these stacks on the side here. So cool. I think it's cool anyway. It's a nice rotor. I'm going to see if I can't get it to work real quick. There he is. Hey, Tiggs. Yeah, I don't know. We'll see. Get in there as close as possible. Spin it. I don't know. I can't really hear it that well. Take these off. Yeah, there's definitely a chance that it's not going to do anything. Yeah, I don't know. See, the power of the magnets matters. It matters a little bit. Heck yeah, man. Those gyros spin like they don't spin on the electromagnets because I don't know how to pulse it right. But they spin when I spin them, and everything just is up and down and sideways and back and forth, and it's just awesome. I think it works the way it's supposed to. Absolutely. Now with the generator light right here, it matters a lot how close uh, the copper is to the wheel. And I think the SSG light is always going to be brighter. Let's move it over so you can see that. But that one is definitely flickering a lot more than the other one is. Can't really see it on the camera. You can kind of see it in the background a little bit. Flashing off the wall. Kitty. Wish I could afford more magnets. Right now, I'm just kind of throwing them back and forth between different rotors and stuff. It's like the one thing that I never could really ever have enough money to get all of them at once that I needed. But I got this 9 magnet rotor. I like this one. It's a little off balance. Not really, though. It's got a ceramic bearing in it. It can go 3 magnets or 9 magnets, and that's it. But yeah, I'm just starting to work with 100% infills. So all my rotors are ending up being a little heavy, which is good, I think. This is 100% infill over here, this 6-inch one. Oh, it's so smooth. The only thing over here making any noise is the SSG. Look how bright that is. That is amazing. Yeah, the SSG was fluxing right there. It's a nice wave. Yeah, you can ask me something. I don't remember. I know that it's like a Touron. It's kind of along the same lines as a Touring, something. And yeah, you know, if you ever play Zelda and you see the diamonds, you like gotta cut that diamond in half the long way and then split it, and it ends up being 45 degrees. I don't recall though. I only saw it once, and I knew that I needed it, but I didn't write it down. Because they went on about it, you know, they were like, "Yeah, this thing, it's perfect for this and all that," and I was like, "Oh man, should have wrote that down." It could be a donut shape though, but it wasn't toroid. That wasn't the word. That would make sense to have a little like donut of a very smooth material to hold the tip in. Yeah, that would make sense. You could work with that. Because, I mean, if you make that toroid out of a conductive material, then everything's kind of linked together physically through a physical connection. Hey, Tiggs. What do you want, little man? Little guy? Here you go. So that's two 100-watt LEDs with 14 volts in and 200 milliamps parallel. That's a parallel circuit. So you got to like do it twice, but it never gets higher than 14, right? It's kind of like man hours. You know, you had 14 people working for 2 hours. So how many hours was that? That's 28 hours, right? Or was it just 2 hours? You know, it depends on how you look at it. But yeah, this is definitely a parallel circuit. So it's going to be man hours. It's going to be 2 hours. It's going to be 14 volts across the board. And it doesn't go above that. unless you add them all together, and you're not supposed to do that. So, I mean, that's something else. That's in series. That's when the volts get added up, it's in series. But what this is saying is that we got 14 volts in and about 0.5, half an amp in. Like 0.2 for the SSG and 0.3 for the 1, 2, 3. That's great, man. That's awesome. I'm not saying anything other than what I see. It's a WYSIWYG, man. What you see is what you get. My circuit over here has no resistance on it, save a light bulb. That's all it gets. And it's the one pulling all the weight right now. Here, let me turn mine off real quick. And look at how slow it's going, and look at what's still coming out of that lamp over there, man. That is beautiful. But there's no kick here. There's nothing here. That's probably because of the transistor, but I don't know. Oh yeah, that sound, man. That's terrible. That's got to be the transistor, or something's touching. And yet it still works, but it's not working. No, that's definitely needs to be switched out. Hey. All right. So nothing's really touching over here. Got it. All right, sweet. All right, so that's my last MPN of that bunch. And then PNPs, man, I have no idea. Huh? I've never got one to work very well. Making sure we're in the clear with the power. Yeah. Because if we could get both of these to, have some thrust to them, instead of just being like a dump. It's kind of what's going on here. The energy is dumping into the light. But this is not working, so I'm trying to fix it.
All right. Oh, let's give it a spin. See what happens. Nope, and that's a fresh one, so that's not what's going on. That sucks. But I bet if I figure out what's touching what, or I can just hook back up to 1, 2, 3, but we'll lose the second light. Awesome. It might be that connection. I hate these connections. So we're just going to go with the 18. Look at this bad animal right here. That's awesome. I'm going to try and get some better clips.
Hey, hey, hey. Don't bite that. You're gonna get yourself killed, okay? Man, he was chewing on the cord for the power of the phone. Man, I get shocked. I hope he doesn't do that. Probably will, though. All right. Sorry for doing that. I hurt my foot a while ago. I don't really have much control. All right, let's fire it up. Volts. No. Oh, it's all right. Yeah. That's not right. Whatever's going on right there is not right. I must have hooked something up wrong. There it goes. As soon as I saw that, I was like, oh, that's what it is. $200 milliamps. If that's off a 32 gauge, so I think that's pretty good. Whew, man, that's speeding up pretty good. So we got SSG and the lamp, and we've got the generator circuit here on the table. This is the generator circuit wave right here. The light is also one of the lights is plugged into that circuit. So when it's on, you get a square wave. When it's off, you get kind of a crooked sine wave. But it's been brought to my attention that it's not a sine wave. But there it is. Just making a simple electric generator transformer. And then we got SSG for one end. This coil is hooked up to SSG, which is right there. And then the light is also hooked to the output of the SSG, the one that's on right now. 15 volts are going into the SSG currently. And this is the wave we're getting off of the generator circuit, which is these two coils at 180 degrees. One's 18,000 turns with the soft iron core. The other is 22,000 turns with the soft iron core. One was wrapped with an electric winder, and the other one was wrapped with a crank winder. The big one was wrapped with the crank, and the second biggest one was wrapped with an electric winder. So the electric winder one is tight. It's more tight, and it produces more in my mind, and it's more crisp because it's so tight. But Occasionally I measure the speed. Yes. Let me check that. All right, so we're about 750 RPMs currently. So it's 3,500 divided by 4. I just 750 is good enough. 4,000 would have been 1,000 RPMs. The speed, the kinetic output of this device would be better without SSG. Because it's a 12 volt system, and the way that I have these set up, they can go well beyond 12 volts. And you can move this, as long as you, the SSG, as long as you put the same amount in that you're putting out. It shouldn't like mess with it. But the amount of speed that I get from is way more because there's no resistance in mine, except for the light bulb that I put in it. So the 120 volt halogen light, incandescent, so it's got the filaments. I don't want to blow anything. Put it up to 20 volts. I'll put mine up to 20. We'll get a speed reading at 20 volts. Pulling about 2 amps parallel. Yep, we're at 1,050 RPMs with an SSG and a 1, 2, 3 at 20 volts in. That is slow. That's slow, no doubt. But we're getting enough energy off of that to spike the meter for one. And light 2 lights that are 100-watt light bulbs. There's a lot of oscillation going on. This light is all oscillation. It's 100% AC circuit. I might run a bridge rectifier through it, see how much DC we can get. When you get all the SSG in here and stuff, it gets noisy. But it's nice. It's nice noise. So I'm just gonna see if it's working. I'll put it up to 9. Something not right about it because it doesn't have the torque. Here, I'll do mine. It's not gonna beep like that one did, but 9 volts. It's got the torque, it's got the speed. Now I know that that circuit will run motor real fast, but it's not working right now. It is pulling like 300 milliamps at 9 volts. That is not right either. Huh. I wonder what it could be. I don't have anything touching anymore. And then it's got to be a transistor, but I just put it in there. It might be, yeah, it could have happened like that. Put the transistor in, and then the outputs were connected together. That could have fried it instantly at turning it on. Like, you are now short one more transistor. See, it's still on. You can't even tell that it was on. $25 off of my circuit, which is this red coil right here, connected to this circuit right here. Oh, you can't even see it. You can't even see me. That's funny. All right, power supply currently 25 volts in. This little transistor right here is the 1, 2, 3. There's no breadboard. Unfortunately, it kind of nice. We're at about 111 watts. I don't know, 1,111 watts. That is so freaking smooth, man. That is unbelievable smooth. I can feel it vibrating though. Very like quick paced vibration. All right, 46. I want to get to 48. We're not gonna do it. Okay, 46.29. 46.30. So that's going to be like 1,300 RPM, something like that. SSG. Yeah, I don't know how many transistors I want to put in there. Especially knowing that I just had a good one and I put a new one in and it blew out. Even if it was something simple, which I think it was. I might try it again later. But for now, I'm going to hook this back up. Got a little 12-volt battery right there. All right, almost done. All right, that should do it. Wow, what a mess, dude. Oh, so I don't want to deal with it right now. Just want to make sure everything is not. I got a lot of it dealt with, but. All right, let's see. Let us see. But as we're going clockwise, counterclockwise oscillation, I don't even know how to do that. This is 1, 2, 3 on the other coil. Right, yeah, man. Now it's double the speed. $111 or 1,100. I mean, yeah. 111. Yeah. So it looks like it's exactly the same at 12 volts. 4,634. Oh no, that was at 20 volts. My bad. My bad. Whew. $15 in. $53. Ooh, wow. 54. $54 divided by 4. It's in between 1,500 and 2,000 RPM, somewhere in there. Why, though? So I can know. No, I mean, I understand why you're telling me that I need to do these things. But for that reason, I do not need to do them. I mean, it feels like you're saying that I shouldn't do this because somebody else has done it before. I couldn't know heads or tails about who's been doing this. Or you just want me to find more knowledge. I don't understand. It's just so, there's so many, like, say you're unaligned, making it very hard to understand. Dane C. Hines has his own YouTube channel and shows on his channel successful. Is that supposed to be replications? I don't know what you're, just because I'm using an SSG circuit does not mean I'm doing SSG. I'm not doing that. Sorry, I'm just using the circuit. I apologize for the confusion. Sincerely. I know you guys are just trying to help out, but I have no desire, need, or any bit to go look at somebody else's SSG because I'm not doing SSG. I'm just using it. I know a lot of people don't understand what that means, but if you just pay attention to what you see and not what's going on in your head, you'll get it. I don't know how to explain it. I'm not faking anything. I don't know how to fake stuff like this. I don't know enough about it. I've only been tinkering with different things for about 2.5, 3 years of my life. That's nothing. Does this even look like an SSG machine? This is not an SSG machine. Yeah. I understand your concern. I really do. But no. Yes! Beat! Oh my God! Beat! Oh, oh, oh! Oh, that's sweet. The plasma reactor. That's interesting. Now, it was explained to me that I could take the positive end and attach it to the shaft, and take the negative end and drag it along the rotor, or almost contactless drag, and it will spin. Anybody else agree with that? As for this though, does anybody agree that I could run an AC power to this and connect one end to the shaft and the other end to the disc and it will spin? The tuning, yeah, man, wow. Thank you, Pete. I knew I wasn't crazy. I'm like, yes, man, yes. Those things are like magic for what they go together. And I never thought that the people that made these things, some of these things, I'm not going to say all of them, I'm saying some of them, like this right here, for me to get this light to light, it does not need to be any certain measurement, it just has to be above a certain measurement. You get what I'm saying? Like it is not. I can't get into it right now. But it's not already drawn out before I start building it. It's never been that way. And I guess that a lot of people don't like that. Rubs people the wrong way. And it's like, because, but me personally, I think a really practical use for a force field would be to elevate our transportation infrastructure so that you can be driving on top an invisible force field, like another road, even just like it's another road. But it's a magnetic thing, man. It's definitely, well, not a force field, but the force, you know. I don't know if you can actually be holding a coil and having feel the force against another coil without getting zapped. I wouldn't even want to try. But I know that when you put a magnet north next to a permanent magnet north, you can feel that. That is a field that you can feel, and it is real. Okay? Anything else leaves questions. But I guess, you know, permanent magnets react real well with electromagnets. But we're trying to get like a force field that can repel like a north-north interaction with the bottom of cars, the bottom of semis, and just hold it up there. I don't know, man. I haven't been able to talk to anybody about it. So, I don't know. It's either, you know, people that know about this kind of stuff are either going to say, yeah, maybe, or they're going to say no. And if there's any yeah, maybe going on, then it's probably definitely a no. So, you know, I don't know. It's probably just a pipe dream of having the cars, even the ones that are around today, being able to fly. Because, you know, all you have to do is put a little boot on them and then you can fly. It's not really like flying, really. You're just being hovered above an existing road network. So you already have a map of the roads drawn out. And then, of course, you'll have your flying vehicles. You'll have, you know, all that other stuff too. But you'll have this for people that can't afford a flying vehicle. But, you know, I have people that say all that stuff is going to become super duper affordable because it's going to become super duper abundant. There's not just going to be one or two of them on the street. There's going to be a bunch of them on the street. You know, personal vehicles are going to become more and more a thing of the past. I love driving, so I'm not looking forward to that. And I've been told that it will happen in my lifetime. It's already happening. I mean, they said that there'll be a boom in truck sales. Every other car is a truck. It's like, yeah, right. But the reason they're booming in truck sales, it's all about the EVs, and they're coming, and they're not going to stop coming. You know, it's going to be the way, and it's not going to be personal transportation. It's going to be public transportation. But it's going to be both, but it's going to be way lopsided towards public transportation. The cars that they're not going to be affordable. They're going to find some way to make it less desirable. And, you know, we're going underground. We're already doing that. That's good. Going underground with boring and stuff like that, making tunnels. But I'm thinking the other way now. Now that we're going down, we should definitely be going up as well. And it should be safe. It should be, you know, it should be fun. Now, if we want to make a movie, like pick two movies, futuristic sci-fi flicks that you've seen that would correspond with the kind of traffic system that I'm talking about right now. I would say one would be The Fifth Element, and I mean, there's lots of them, but two would be Star Wars Episode 2. And why can't that happen? Why aren't we working towards expanding the capacity of the roads that we already have without, just totally building new ones? You just retrofit each road with this force field jazz, and voila, you've got a whole nother road just right there. It's already drawn out. It already goes to where it needs to go, and it's right on top of this one, virtually. That's just what I hear, but that would suck if they make owning a car difficult. Because I approve of all the forward motion with all the car stuff. I think it's great. I think we're headed in the right direction. See, now it works really good. Yeah. That's so cool. And let's see what we're making on our 180 AC circuit. Wow, not much. Let's see what happens when we do this, though. $76, and the light's on. That's pretty good. All right, here we go. Let's juice it up a little bit. So 9 volts in parallel, so it's like 9 volts and 0.5 amps. $500 peak to peak. That's not a big deal. I always thought it was neat, though. 160 peak to peak with the square wave. Alright, I turned it up to 12. For 12 volt system. Now let's turn this off. $600 something. 700 something. As you see those waves getting bigger, bigger, but that just looks that way, I guess. I appreciate people who replicate. Replication is a good key to understanding stuff. But I've never done that. I bought some stuff, but I never replicated anything. And then if the numbers are different, they're supposed to be different. Knowing what your power does. You gotta know what it does and what it can do, what it can't do. But like, as for like what people do to make their meter right, I have no idea what that means. Put a resistor here. Why? Why? Why would I add resistance? I don't know. I don't know. Because it's not naturally there to begin with. It wasn't there to begin with. So, I mean, why do I gotta add? It's not like in what you add, it's what you take away. It makes it something beautiful, right? Especially when you're dealing with sculpture. Absolutely. So that's 230 AC volts at 12 volts in, 12 DC volts in. All this is made from magnetic induction, and I've been told that it's nothing. All right, now that nothing is going to turn that light on. That's a 100-watt light bulb. it's nothing, right? There's now a load on the rotor. That is something. It's definitely something. No, it's not nothing. And it's not nothing because I didn't write the math down. Of course, I've done like some number crunching, but I don't need to write it down. I don't like things that are written down. I don't know, that has a way of influencing people, without a doubt. Now, a text message, I can roll with that. So what do I want to do? I have an AC power supply that's can manipulate between 0 and 130 AC volts with a 120 input at 60 hertz. I was wondering if I should try and get this thing to spin the way it was explained to me. I don't know if I got the right kind of shaft. It's very non-magnetic. I mean, it probably has magnetic principles, but you can put a magnet by it and it won't do anything. But I got these long ones that are very magnetic, and you put them in, it's just the magnet goes whoosh, right to it. Now, the thing, I don't like putting together jigsaw puzzles. I don't like jigsaw puzzles. Hey, maybe I'm in the wrong field. Just kidding. another idea. Put this on the bottom. Oh man, where did I put the, there it is. There's like no magnetic pole there. But I might have to switch the orientation of the magnets slightly. I'm gonna put it in close though. That'll take 5 minutes. Let's do it this way. I might need another bearing, but that's going to take off for sure. So I'm going to get the 2 coils, or maybe just the 1 coil now. Actually, I need to change the orientation of the magnets for this to work right. But I get some eddy currents off of this with just this simple coil right here. By putting it on top here, you see how you got motion? You remove that motion and you're going to generate eddy currents. More eddy currents. It'll generate eddy currents like this as well, but just not as many. And you can convert that into DC voltage through a bridge rectifier. Now I tried just hooking it right up to the coil. It zeros across the board is what I got. But once we hook that coil up to a bridge rectifier, we got a reading. So let's see if we can get a reading on the one on the bottom. No, there's no reflection. That would have been useful for me to put some holes, but that would be less material holding it in there. Okay. So, 41. Okay, we got about 1,000 RPMs. We get a slight braking effect putting that on there. But again, that's generating more eddies. Yeah. So I can put it right on the disc without it being wrong because of the bobbin that I used to build it. It's plastic and it's insulated, so it's not actually touching the disc. So that's cool. But like if I get, I don't have one right now though. Maybe this. This is one of those magnetic poles I was talking about. We can get that going at a pretty good speed.
Oh, that's cool.
Yeah. And that is aluminum on permanent mags.
It's working because there's a magnet on there, and it spins that.
And then like if I grab that and stop it from spinning instantly, it'll act as a brake. Like a pretty stopping brake, like good brakes. Bye. Alright. Look at that, man. It's spinning and there's tape on there. You can't even tell there's tape on it. So cool, man. That is neat. But that's like, because the north face is facing out. So, and then this way they're both facing up, but they're going like this instead of like this, which will spin it very slowly. All right. Yeah, it must have packed up the goddamn bridge rectifiers. I have a few lying around. But I don't think I put them in the bag like I was supposed to. Oh man, oh well. But you get the idea. I love the sound of that motor, man. It is quiet. Like unbelievable in comparison. Move those out. What do I want to do? I want to test that. So I want to do I might have to file down the shaft a little bit. Yeah, gotta file it down a little bit. And then put the negative node on here, right on the disc. But of course, you know, I wasn't planning on doing that. So I think it's a good idea. See if we can get it going like that. All right. Just looking around. That is pretty much a treasure, though, to have a Bedini site with all the right information on it. I mean, that's worth quite a bit, in my opinion. I'll definitely check that out. All right, so no, that's funny. Like, sorry to ruin your flourish, but yeah, we gotta bail, man. Where we gotta go? Well, I'm not gonna get into it. Wow. Wow, dude. I can feel what's coming off of this thing. It's a lot. Wow. That's the 18 gauge and 20 gauge coil, man. That is a powerful piece of coil right there. Thanks, Pete. Heck yeah. Pretty much any time at the moment, I need need a lot. It's all right though. Oh wow, and that was with the coils backed out. So the light lit up with the coils backed out. That's pretty cool. And this is big red right here. I think it's wrapped a completely different way than the other coil. In repulsion phase, it's wrapped an entirely different way. And it's 20 and 22 gauge instead of 18 and 20. So I'd say it's a little less powerful that way, but it's a lot more wire. It's a lot more wire. They're both trifiber coils, so similar in that way. This is 32 volts in. Wow. Wow, that light's getting bright. Holy cow. Sweet, man. It can take a lot of voltage. But that light gets hot, it gets bright. So I don't know, I haven't, I'm doing a little bit more research, I guess. I mean, I just dove right in. I'm like, I mean, you can even look. I started off with like 32 gauge and a wooden rotor and all this wood. And then I got my first 3D printer. You can see the evolution of what it started out as to what it's become. And I do a lot of different things. You know, I paint, I like painting. I do this as a hobby. Those are the two main things. I play a lot of games. People think it's a children's thing to play games. Play games with your kids. That's all I'm gonna say. There's nothing childlike about playing with your kids. If they like playing games, or you know, if you can get them to play games with you, you know, all the more. Well, some games are going to be inappropriate. I understand that, but you know, you play a game with them that you like, and they like start to play it, and they like it too. That's a win-win scenario. And there's nothing childish about that. That's my angle. I mean, if the ultimate end goal isn't about you, then you win. And it's a catch-22 like no other, but it's true. It's all true. Heck yeah. And it's like a test. It's like, are you gonna be truthful to yourself and what you believe in? Of course you are. And even if you start off not believing that way, you will end up believing that way. I don't know. Can't tell you what you're going to believe. I just know that and all these U's that I throw out there are really I's. It's an I statement kind of thing. I feel this way. about my situation, and I think that games shouldn't be tied in with being a child. Really. I mean, some people do it just to relax. It's not like they're doing it all the time. I admit, if you're not getting paid and you do it for a living, that's wrong. Okay, you either get paid doing it, if you're doing it for a living, or you need to do something else as well. You can't just play video games all the time, not get paid for doing it, and expect that to be okay with everybody. It's not okay. If you are financially dependent on somebody else and you play video games all day, that is not okay. Just a personal belief, you know. I don't like presume that anybody. You don't even have to listen to what I'm saying. I'm just saying that because I believe it's true. I'm not judging anybody. I mean, I could tie a judgment within that very easily, but I don't know if that would be true. That wouldn't be true necessarily, because that's my high take on the whole situation and how you play a part. And that is a you. That is a real you. How you play a part in the situation. I can't possibly know that to a T. I mean, you can get close. But even if you're taking the time to get close, are you on the right road? Is all the question I have to ask of you. If you even, I don't even know, man. I don't know. I'm probably not making sense right now, which is not good. I think I lost my train of thought twice in that whole debacle right there. Wow, I love it. I love it, I love it, I love it. So you put the same amount of voltage into each coil, and that levels it off a little bit, so it's not fighting as much with itself as it was previously. Because you got 18 and 20 on one side, and you got 20 and 22 on the other side, and you got a lot more of 20 and 22 on the one side than you do of 18 and 20 on the other side. So all I'm trying to say is naturally, if you put 9 volts into the 18 and 20, you're going to get a much more demanding amp draw than with the other coil. Just for the fact that it's a thicker gauge wire. I mean, it's weird because you got the same gauge wire in there because you got 20 in both, okay? And then it goes step down in the red coil to 22 and step up to 18 in the other coil. So yeah, I mean, I don't know if any of those, combinations mean anything. They probably don't, but oh well, I can see them and they're there and they're real. So, do they mean anything? Probably not. But I can definitely see that there are some similarities and some differences to both of our drive coils. Now the trigger is the same in both. You get 32 and 32 in both coils. Thanks, bruh. I have no idea, man. I don't know any aliens personally, but but this is a DC brushless motor. It's totally brushless. I got hooked on the parallel circuit a while back. I used to run all my parallel circuits on the same power supply with an Eve model power distribution block. So you just plug the power supply into the distribution block and then you get 10 positive and negative connections. And the only thing that should go up on that parallel connector is the amps. The amps go up. So you put it at 12 volts, all of them get 12 volts, and then whatever amps are required to run the circuit. Ooh, man, I'm getting hot. Hope they didn't turn up the heat. Maybe it's because it's like 50 degrees outside. Does anybody like feel like it's unseasonably warm? Or is it normal everywhere else? Just weird here. Oh man. And then I was running a reed switch, which is right here. Off of the transistor, which was pretty fun. But it's like it's nowhere near a trigger coil in regards to frequency. And with a reed switch, finding the optimal position isn't always the easiest thing to do, especially if you're working with Hallbeck arrays. That is so cool. Unbelievably smooth. See, this is where it gets really like different because you put 15 volts into the big white coil over there and it's drawing virtually half an amp, 400 milliamps. But I'm pretty sure this one isn't even drawing 100 yet. Maybe 100. It's low, that's what I'm trying to say. It's like, and you can't really tell because it doesn't have a meter. Yeah. So, I don't know. It is kind of going to be my hallmark phrase, man. I don't know. I really don't know. I know I've heard a lot, but I can't say that it's all facts. And I haven't haven't done I don't have enough knowledge to form an opinion of my own. But I do know there are some thresholds, that you don't cross. You're not supposed to cross. And they say that you're not supposed to cross them because you can cross them. That's not the problem. Okay, crossing the threshold is not the problem. I don't know what the problem is. I don't know. Okay, that's my answer. I don't know. I just know they say you're not supposed to do such and such a thing, or do this such and such a way, or leave out any pieces, or whatever, man. I mean, I don't know. It's the honest God's truth, man. I feel like saying whatever all the way up, but it's like, I don't know. Maybe you're right. But this looks real to me, man. This thing is spinning. I don't see where I should have to stop. You know what I'm saying? I don't see where that is. Show me the scat, dude. That basically means show me, prove it. And there's got to be evidence that qualifies as evidence. It can't just be coming from your head or your boy's head or your congregate's head or any of your clique. It's got to actually be coming from somebody who's opposed to you for it to really count. And that's good. You get somebody who's opposed to you on other issues to agree with it. Yeah, man, that's damaging if it's against somebody. But I don't know. It just appears to me that would be a way to back up what you're saying, is if you get somebody who's not of like mind to back you up. Place is kind of a mess right now. Heck yeah, man. Anyway, I've had a blast doing most of this stuff for most of the time I've been doing it. unfortunately, some of the time, I don't know, man, maybe we could make some collaborations, maybe we could have some conversations. But I really can't give an educated opinion because I don't educate myself. So that will be my official opinion, is I really don't have an opinion that matters because I don't know anything about Rotor coils or Tesla coils. I don't know anything about it, so I don't have an opinion. I think they're cool. And, I've never really believed in doing what somebody else has done. And it could be because I don't think I can do that, but I've done it before. I put together a jigsaw puzzle before. And that's pretty much all it is. The picture's already there. You just have to take the pieces and put them together the right way. And you make the puzzle. And that's how everybody does this. It's like they already have the idea of what they're going to do and why they're doing it made up before they start doing it. I didn't do that. Well, my idea was I want to make this move. It didn't really matter about the electricity. When I found out I had to put electricity in it, I bought a battery. Okay? That's what happened. I was using purchased solenoid coils. And they worked okay. They were very slow. It was very slow in the beginning. And I made my first coil and it worked better than all that crap that I was buying. So I'm like, okay, I get it. I like it. I can do this. The first coil I made was, like I said, better than anything I bought. And it was just this big. 32 gauge. Single file. Man, it crushed everything that I bought. And then I made more. I found out that position was very, key to having more of them. You need to put them in the right spot, especially if you're using a reed switch. They had to be lined up with the magnets in order for that to work. You could adjust the reed switch, but you wanted those magnets and to be lined up with the coils. Yeah, you did. And you didn't want the coil, like I said, like I showed you, the coil was really small. Not like miniature, but it was small. But it had a nice big axle, like a wide open axle, so finding a core for it was not easy. All right. Anyway, I got 2,500 videos or so. Yeah, you can check out any of those. I started working with magnets only, actually, and I used DC motor. Not on anything like this, just something I bought at the store. And all those experiments are on there too. Really cool. I think, anyway. All right. Yeah, check it out. Peace out. Like, subscribe, hit the notification bell. Peace out.